Okay, friends, so I have other studies for us to look at too besides this one. And this one raises a whole bunch of questions with me anyway. Like, I don't know if you noticed, but it was done on college-age kids, and they're talking about brain development. So how much brain development is happening at college age versus, say, kindergarten age? Something else that's interesting is when they talk about handwriting, they're talking about cursive, but how about printing? Are there similarities in printing versus cursive? So there's some research kind of weirdness in there, but I'm going to try to ignore that and focus only on their results. And the results were this little thing down here called the p-value. So this little thing in the paper right here, p is less than 5%. I'm not sure why it has the p is greater than 0. P is a probability. The p-value is a probability. I'd like to apologize for all statisticians. That P right there is not the same as the population proportion parameter that we also use P for. As a matter of fact, and you'll see this in the next few videos, I always use a capital P for a p-value, not a lowercase p, because I want to draw out the distinction. It's contextual, but we could be less confusing if we just used a capital P. They didn't. Maybe it's a Norwegian thing. I don't know. Or Danish or wherever they were from. I forget now. What does that p-value mean? Well, here it is in words and writing, and we're going to look at it more carefully with the next couple examples. The p-value is the probability that you got the results you did given that the null hypothesis was true. The chance you got the results you did given that the null hypothesis was true. Now here's what I mean by that. Let's go back to this little curve that I drew on this sideboard here. Okay, now you remember the p-value from this study was less than 5%. This confidence interval right here is 95%, and it's no coincidence that 95% plus 5% equals 100%, because this 95% is the sampling distribution, the other 5% are in the tails. And that's why the small p-value of less than 5% implies we should be believing the research hypothesis. Because if the p-value were large, that would have implied we landed in here. If we land close to average, that means we believe the null hypothesis. But if we land far away from average, that means we believe the research hypothesis. So that p-value that it told you when it said it is less than 5%, less than 5% means different enough from what was being expected. Assuming that there was no difference, assuming they were equal, what's the chance we landed outside of what was expected? And because the results they got imply that there definitely is a difference, their conclusion, therefore, is the brain development with cursive versus typing is significantly different. Okay, I think we've had enough of this study. Let's switch gears onto another study. Again, same kind of apology. The study has already been done. We're going to do our own calculations starting next week. But for today and for the next day, we're going to look at studies that are already done because I want you to see those p-values in context. And I want to be able to tear apart those p-values and see what they're actually telling us. Okay, check out the next video.